morning and Assalamu alaikum everyone. My name is Samia Ikram and my group members are Shazameen and Ayan Ahmed. We are presenting our group project titled as Solar Panel Sun Tracker using ESP32. So basically our project is a part of our ICT Mechatronics course and its main idea is to align a solar panel with the sun to improve its efficiency. Normally, the solar panels are fixed in one direction, but the position of sun keeps changing throughout the day. Because of this, the panels are not always at their best angle, and lot of potential energy is wasted. To solve this issue, we have built a system that can automatically follow the sun, so the panel can capture more energy. The main objective of our project is to design a low-cost prototype solar tracker. We have used ESP32 as a controller, LDR sensor to detect a maximum sunlight, the motors to rotate the panel, and our goal is to demonstrate a tracking system that can improve the effective performance of solar panel compared to that fixed ones.
Basically, in this, the code defines that the ESP will start the relay LDR and the motor will start. We will set the maximum value that's coming from the LDR to 0. We will initially move to the left if the value, which is maximum, first input, keeps decreasing. It means the left light on the left is decreasing. Then it will automatically shift to the right. When it shifts to the right, it means the right intensity will increase. The light intensity will keep increasing as soon as it reaches the maximum value. For example, if it reaches 5 and the next value is 4.9, it will stop at 5. After that, the motor will stop and light will continue to be received there at its maximum intensity. It
Now let us give you our system overview. In simple words, this is how our system works. So basically, the input is the light intensity values from the LDR sensor. The controller which we have used ESP32 reads this value and decide in which direction to rotate. The output is the movement of motor, which rotates the solar panel towards the direction where light is stronger. This way, the panel keeps facing closer to the sun direction even during the day. Now, if we talk about the hardware components used in our project, these are following: a 10-watt solar panel, ESP32 developed board, 2 or 4 LDR resistor as per use, a motor driver, a DC gear motor, a battery that provides the power to the system. Along with these, we have used a breadboard, some jumper wires, a simple mechanical frame to mount the panel. Now, if we talk about the working principle of our project, the LDR is used to detect light. The more light we follow an LDR, its resistance will change and the voltage at a point will change as well. Then we will read the voltage using the analog pin of ESP32. We will place LDR on the left and right side of the panel. The left side LDR reading is higher than the right side when we rotate the panel towards left, and the reading of right side is higher when the panel will rotate towards right. When both readings are almost equal and their difference is small, we will stop the motor and it will mean that the panel is aligned towards the sun. Now let us talk about the control flow in ESP32 algorithm. I will explain you the basic control logic running towards ESP32. First of all, we will initialize all the pins, which include LDR input pin and the motor output pin. Inside the main loop, we will read the LDR values for the left and right side. Then we will calculate the difference between these two readings. If the difference is greater than a certain amount, we will rotate the motor in the direction where the light is stronger. And if the difference is within the amount, we will stop the motor. This process runs continuously in a loop, so the panel keeps adjusting itself throughout the day as the light changes. Now let us talk about the circuit and mechanical setup. As you people can see our circuit and mechanical setup, let us explain this briefly. The ESP32 is mounted on the breadboard. Then LDRs are connected to the voltage divider to the analog pin. The motor driver is connected between ESP32 and the motor. The motor are powered with a separate high voltage supply such as 9 to 12 volt. As we keep a common ground between ESP32 and the motor driver so the signals are referred correctly. Mechanically, the solar panel is fixed on a rotating frame that is attached to the shaft of a motor. Now, if we talk about the result in our observation, these are following. During our testing, we have moved a light source to the left and the right side of the panel. The system automatically rotated the panel towards the brighter side. This shows that our tracking logic is working correctly. This experiment shows us that in a real outdoor environment, the same principle would allow the panel to follow the sun over the day, which would result in more energy production compared to the panel which are fixed in a one position. Now, if we talk about the limitation and challenges faced by us during this project, then these are following. Firstly, there is only a small scale prototype, so the mechanical structure is not strong enough for heavy and large panels. Secondly, an LDR based tracking system can be disturbed by clouds, shadows, or artificial lights, so it is not always perfect. Thirdly, we don't have any specific precise angle feedback, so there is no encoder or angle sensor in this version. And at last, we have not yet done a full analysis of how much power we have gained and how much power the motor consumes. So there are areas which can be improved in future versions. Now, if we talk about the future scope of our project, then we have several clear improved ideas. First of all, we can implement two-axis tracking, so the panel can move left and right and up and down as well. Secondly, instead of using LDRs, we can use mathematical sun position algorithm based on time, date, and location to calculate sun's angle. Third, we can add current and voltage sensor to log real power data and properly compare a fixed panel with a tracking panel. Fourth, we can design a custom PCB and a stronger mechanical structure for more stability. And finally, we can add a IoT feature so the system can send data and status to the mobile app or a web dashboard. Now, while concluding this video, I would like to say that our group has successfully implemented a solar panel sun tracker prototype by using following components: ESP32, LDR sensor, relay, a motor, a power supply. By using all these, we have automatically rotate the solar panel towards the direction of maximum sunlight. This project demonstrates that automation can improve the effectivity and efficiency of the solar panel. And with the further development and scaling, this concept can be used in real-world solar installation. Thank you for all your attention. We